So hello, this is Raphael Walter. I'm going to do the same demonstration but with a different set of data than the previous video that I've made demonstrating the graph, the predictive, and the text analysis. So basically, I was able to go into the SNCF, which is the railroad system in France, it's a company, and they give us access to a lot of data concerning all the railroads, stations, and the lines and incidents that were on the lines. And you can basically get all this information either in JSON or Excel or CSV files. So the idea is the same in this case. I basically got the graph. I wanted to do a graph by looking at the railroad stations, and then I wanted to be able to also show the relationship between the stations. So basically, a station is linked to another station. It's a two-way relationship. You can go either to that station or from that station. And so in this case, as you can see here, I created a graph workspace. So giving the station as the vertex and the edge will be the relationships between those tables. And then I create the graph system. And then once you've done that, you're able to create. So I'm just going to connect to my database. Once you've created this graph workspace, then you're able to perform some kind of calculation scenario. So this is the object of this bottom here, create a calculation scenario. And in this case, I have a start vertex with the railroad station, target vertex. Then I'm going to use a weight, which is going to be the distance of the relationship, because let's imagine there is a distance of x kilometers between this station and this station. And then I'm simply going to get a result here. So then you can show the result here. So I'm going to get this. I'm going to execute this query. So once I've done all the analysis, and you can see starting from Vitrolles Aéroport Marseille Provence, and if I wanted to go to Brunstadt, which is the ID that I used, then this is all the different stations you would have to go through. And this is, of course, the shortest path, but using the distance as a weight. I could have used maybe the time. Maybe between two stations, it's going to be quicker, even though the distance is longer, etc., etc. So the shortest path using distance as a weight could be different, entirely different, using the time as another weight feature. So this is actually not really a very friendly way to look at the data. So as you know, there is a HANA Graph Viewer that is available. It's meaning that you could launch the single source shortest path here by using the start vertex and the target vertex using the weight calling. Then you simply execute this. And then, of course, since I have 7,000 railroad stations in France, as you can see, this is actually quite a lot. And here you see the same result that I showed you a few seconds ago. Okay, so this is what you have. So then the second thing that I wanted to do was here. This is the incidents in the different train stations that we have. So there's the ID, the train station name, where it is, if there is a specific location. And then you have the comment, which is a comment that I've loaded into HANA as a blob. And then, well, basically this is a free text, so you don't really know what really happened. So there are a few thousand incidents loaded. Okay, and basically what I want to do is I want to be able to retrieve automatically information about this. So to do this, I'm going to do a semantical analysis, so by creating an index and using extraction core voice of customer here, as you can see. So once you do this, you're able to create the sentiment analysis index table, and you can retrieve all the information. So basically, if I went here and I want to see, so I had basically no idea, but by running, still no connection to database. And if you run this, sorry, my bad. I included the creation table statement. And you can see, sorry, the stations, the year, and the type of incidents with a count. Basically, if we go to this station in 2018, there were 2 major problems and 1 minor problem here. And this is again a way to look at the data. A nicer way to look at it, I'm going to be using SAP Analytics Cloud, and I've done the sentiment analysis, and we see here the major problems, minor problems, requests, and contact demand. This is the whole spread of in a pie chart of my problems, that the issues we had in the stations, and basically here you have the 20 stations with the most problems, which is in Lyon. But actually, if you look Paris, there are a few stations in Paris, Saint-Lazare, Bercy, Montparnasse, etc. So if you sum them up, there actually are going to be more problems in Paris than in Lyon. But you get the idea, and you see the spread. So basically, I didn't have to go through the whole unstructured comments, but I'm able to retrieve. Of course, maybe there will be a few issues in this, and maybe an incident flagged as a minor will be a major problem or whatever. But basically, this is a good way to look at the data. And the idea is here we're using HANA to structure unstructured data and to be able to perform BI on top of this data. The last part was again a k-means. So I have information about my stations, and sorry, and if I look at my data here, I have the incidents now, but I also have the frequentation, how many people went into the station. So maybe there is a correlation between the incidents and the frequentation. Of course, more people are going to be in it, the more there might be issues. So basically, as you know, in HANA, there are a few PAL predictive algorithm, and you have 2 ways that you can do PAL, either with AFL, which is an automatic functional library, or the PAL, which is a predictive algorithm library. And in this case, I used the PAL one, so meaning that I have to define everything here. So I'm creating a parameter table, filling in some information in there, creating the data table, because it has to have a specific format here. And then I'm simply going to execute a procedure that you can see here. It took me a while to figure out all the information, especially the result tables and the file format, the format of those tables that were needed. So I've declared a few types here that you can see here, so that it respects all this information. And then once you've run this procedure, you basically can see the results, and then you have a clusteration. Your stations are going to be clustered, and I've asked for 4 clusters, and you retrieve the 4 clusters, and you're able to get all this information here. And then once this is finished, you retrieve and you can show this information with the k-means clusterization. And here I have the map, and all the clusters are going to be available. And you see here actually Paris and Strasbourg, which are main cities, are clustered as 0. But strangely, oddly enough, you can see that here in Le Mans, we also have a station that seems to be of a cluster 0, which is actually quite strange. And we would have assumed that only really big cities would have those cluster 0, and it's actually uh, um, a lot more are present, and not just in the big cities, and you also have it in smaller cities. So basically, if you use the human to cluster, then we would definitely not have come up with the same. So this is using HANA for artificial intelligence and machine learning and to retrieve information. Then we could try to look into the model that was created and try to understand why those smaller stations had the same cluster as the big stations. Thank you very much for your time. Sorry for my voice, as again, I'm always sick doing those videos. Take care. Bye bye.